This makes learning so easier.
It is beautiful. And now let's enjoy the nature. Back to the classroom. I'm Anil Kumar. Welcome to Anil and Gurmeen series on polynomial functions. Now, take this video as a test preparation for polynomials, long and synthetic division. We'll have a couple of questions here. Some of them will be multiple choice questions. Just go through these questions one by one. You should actually copy them, solve yourself, take it as a test, and then look into my solutions. Please also watch our video on long and synthetic division to understand the basic concepts, and then take this as practice test. Question number 1. Perform long division and express the answer in the form of f of x equals to dx times qx plus rx. Now, the f of x is the function which is being divided by the divisor d of x. You get quotient q of x and the remainder r of x. The function given to you is 2x cubed minus 3x squared plus 1, and the divisor d of x is x plus 2. Right? So that's the question which you need to do. Question number 2 is perform synthetic division and express the answer in the form of f of x equals to d of x times q of x plus r of x. This time the function given to you is x cubed minus 2x squared plus 3x plus 5. You have to divide by a linear factor x minus 1. Now, if you get a remainder which is non-zero, then it is not a factor. If you get 0 as a remainder, then it is a factor. Question number 3 is determine quotient when 9x cubed minus 3x squared minus 4x plus 1 is divided by 3x minus 2. Use synthetic division. Question number 4. Derive the formula x cubed minus a cubed equals to x minus a times x squared plus ax plus a squared. Now in the next chapter we are going to do factoring and factor theorem. So this will be handy in factoring difference of cubes. Question number 5 is when certain polynomial is divided by x minus 2, its quotient is x squared minus 2x minus 3 and remainder is 1. What is the polynomial? Question number 6. F of x equals to dx times qx plus rx, and rx is not equal to 0. With the degree of qx as 4 and degree of dx is 2, find the possible degrees of rx. Qx is quotient, dx is divisor, rx is remainder. Question number 7. Now we are really getting into some very difficult thinking and application questions. I would like you to understand them. Take your time to answer them. Question number 7 is if f of x is divided by x minus a, the quotient is q of x. So think like this. You are dividing f of x by x minus a and you get quotient q of x. And the remainder is r1. This is first step, right? Then if q of x is divided by x minus b, that is to say, then it is q of x. That quotient is being divided by x minus p. In that case, you get the final quotient and some remainder r2. That's the second statement. Find the remainder capital Rx when, that is to say, the final condition is find the remainder capital Rx, that means the remainder capital Rx when the function f of x is divided by x minus a times x minus b. Do you get it? And all these options are relating this remainder with previous two remainders. Now this is a very important question. I would really like you to think over it, then solve. Now let's get to the next question, which is question number 8. If f of x is divided by 2x minus 1, the quotient is q of x. So think like this. What we are doing here is we are dividing the function f of x and by 2x minus 1, by 2x minus 1, and we get a quotient q of x. And the remainder is r of x. Is it okay? The second case is if f of x is divided by x minus half, if f of x is divided by x minus half, the quotient is small q of x and the remainder is r of x. Do you see that? In that case, which of the following statement is true? Now we are given 5 statements. So then you kind of do your algebra and figure it out. So I hope that question is also absolutely clear. Now let's move on to question number 9. Here is the last question of this series. Question number 9. Apply division statement to find remainder when f of x equals to x cubed minus 3x squared plus x minus 2 is divided by x minus 1 times x plus 2. Now it is a very important question, kind of difficult. Normally the division statement you work out with linear divisors. This time we have a quadratic divisor. So one of our questions which we have dealt with earlier can help you solve this very easily. Okay. Now let us solve each question one by one. Question number 1. Perform long division and express the answer in the form of f of x equals to dx times qx plus r of x. Now in this statement, f of x is a function which is equal to divisor times quotient plus remainder, right? So that's the division statement. Now let us see how to divide and then write the answer in the given form. In our example, we have to divide 2x cubed minus 3x squared plus 1 by x plus 2. So x plus 2 is the divisor and the function is 2x cubed minus 3x squared. You will note that x term is missing. So minus 3x squared plus 1. In between, we should put the placeholder 0x. Now it is very important to understand that all the terms should be recorded in the dividend and the divisor while doing long division, right? So we placed a placeholder value 0 for x. Now the constant term 1. Perfect. So that is the first thing which you learn here. That is, ensure all terms are written. Use placeholder, which is 0, right, for missing terms. Correct? Now when you divide, you have to divide 2x cubed by x to get the first term in the quotient. Now it's a cubic equation divided by linear, so it has to be quadratic in the quotient, right? So 2x cubed divided by x is 2x squared. And that's how you get the first term in the quotient. Now multiply 2x squared with each term. So you get 2x cubed plus 2 times 2 is 4, x squared. Now you have to take away, just as you do in normal division. So take away, right? So that's the operation. You never write negative, but I'm just writing to give you a reference. Now when you take away plus 4 from minus 3, you get minus 7, right? So you get minus 7x squared. Bring down the next term, which is 0x. So minus 7x squared should be divided by x to get the next term in the quotient. You get minus 7x, right? So when you multiply, you get minus 7x squared, minus and minus 14x. Now when you take away, that minus 14 becomes plus 14, and these two cancel out. We are left with 14x plus 1. 14x divided by x will give you constant 14. So when you multiply by 14, you get 14x plus 28. Taking away 14x cancel, 1 minus 28 will be minus 27. So the quotient here is 2x squared minus 7x plus 14. That's the quotient. So we write quotient as qx here. The remainder is 27 minus. And that's the divisor given to you. So the statement can be written as f of x, which is 2x cubed minus 3x squared. No need to write the placeholder now. Plus 1 is equal to divisor, which is x plus 2, times the quotient, which is 2x squared minus 7x plus 14, plus the remainder, which is minus 27. Right? So that is what you get as your answer. So I hope the steps are absolutely clear. Now let's move on and answer question number 2. Now in this case, we are going to use synthetic division, right? So let's perform synthetic division. The function given to us is x cubed minus 2x squared plus 3x plus 5. Let's only write down the coefficients, which is 1, minus 2, plus 3, and 5. The divisor is x minus 1. What really makes it 0? We should say x minus 1 equals to 0 for x is equals to 1. So we are dividing by 1, correct? Now, as you have seen in long division, basically you are always working with the coefficients. So writing coefficients help us to get the result. Bring down 1 as such, times 1 with 1, you get 1. When you add them, so whenever you're going this operation, we are adding, right, going downwards. And whenever you're going kind of like this, we are multiplying. So that is how it really works. And these two steps are repeated. So we get minus 1 when you add these two. Multiplying, we get minus 1 here. Adding will give us 2. And multiplying will give us 2 here. Adding gives us 7. So 7 becomes the remainder for the given case. So that is the remainder, right? This is the remainder. So remember, when you do synthetic division, what you get here is the quotient. So this is the quotient part. And that is remainder. Now, since we are dividing cubic with a linear, quotient should be quadratic, right? So degree is 2. So we'll write the quotient as, in this case, let's write the statement as such. So the function itself could be written as x cubed minus 2x squared plus 3x plus 5 equals 2. Quotient is quadratic, and these are the coefficients, right? So ax squared gives you 1x squared minus x plus 2. Right, so that is the quotient, right? I should have written the divisor also, which I missed, but we can write it later, times x minus 1, and then plus the remainder, which is the number 7, right? So that is how we should do it. Now, it should be very clear that the quotient is degree 2. How do we get it? X cube is the degree, that means degree is 3, right? That is for the function, and for the linear function degree is 1. Their difference of degree is 2. So quadratic quotient. Is it okay? So that is very clear. Perfect. So let's move on and check question number 3. Determine quotient when 9x cubed minus 3x squared minus 4x plus 1 is divided by 3x minus 2. Use synthetic division. Now here some students can make a mistake. How? I'll tell you. First, let's write down what the function is. All the degrees are mentioned, so it is 9 minus 3 minus 4 and plus 1. As far as the divisor goes, it is 3x minus 2 equals to 0. That gives us x equals to 2 over 3, right? So we have to divide by 2 over 3. Now when you divide by 2 over 3, let's divide and see what we get. Bring down 9, so multiply by 2 over 3. So when you times 2 over 3 with 9, what do you get? Let's do it on the side. So we are doing 2 over 3 times 9, so that divides, we get 6. Do you see that? So when you multiply, 3 goes 3 times and we get 6 here. When you add them, we get plus 3. Multiplying, denominator cancels, you get 2. Adding will give us minus 2, right? Now this time when you multiply with minus 2, you really get minus 4 over 3. So what is the remainder? When you add these, the remainder is, we are doing 1 minus 4 over 3, right? So when you add these, you get 3 minus 4 over 3, which is minus 1 over 3. So you get minus 1 over 3 as the remainder. Now it is important to note that you actually divide by 2 over 3. So if you look into the divisor, let's look into this divisor. It is 3x minus 2. So what you did was, you took 3 common, you're left with x minus 2 over 3. And that is this 2 over 3. You did not divide by 3. Do you understand? Correct? So we'll write the quotient as, you have to divide this by 3, all these numbers. You have to divide this by 3 because of this 3. You get my idea? Because we have used the factor x minus 2 over 3, not 3 times. So now you get quotient coefficients as 3, 1, minus 2 over 3. However, the remainder remains same. So what you note here, that in such things, remainder remains same. Okay. Now, since the degree difference is 2, we are looking for a quadratic quotient. Clear? Of the form ax squared plus bx plus c. So the question is, provide quotient, right? So the qx is indeed equals to 3x squared plus x minus 2 over 3. So that is your answer. Do you get it? Very important exercise. Now, look at it very carefully. We actually divided by the factor x minus 2 over 3. We did not divide by this 3, which you have done at the end. And that is how you do synthetic division when the divisor has term like ax plus b. Okay? So let's move on and take up question number 4 now. Question number 4. Derive the formula x cubed minus a cubed equals to x minus a times x squared plus ax plus a squared. What we see here is that remainder is 0, right? So the remainder basically is equal to 0. Do you see that? So that term is not there. It means x minus a is a factor of x cubed minus a cubed. Perfect. So what we are going to do in this exercise is basically divide x cubed minus a cubed by x minus a. Correct? That's what we are going to do. So let's do it. So let me do long division. Right? Now x cubed minus a cubed, two terms are missing here. Those two terms will be replaced by placeholders. So we got 0x squared plus 0x minus a cubed. So remember, a is a constant. A is a real number. Let's say a constant is okay. So we are only working with one variable equations. And the divisor here is x minus a. So in the quotient, taking these two terms, we get x squared. So when you divide, we get x squared minus ax squared. And when you take away, we get ax squared plus 0x. So we have to multiply by ax. That gives you ax squared minus ax, a square x, right? And that gives you a square x. Bring down the next term, which is minus a cube. And that should go times a square, right? So when I write a square, we get a square x minus a cube, and the remainder is 0. Do you see that? Since the remainder is 0, we know x minus a is a factor, and we could now write that the function, which is x cubed minus a cubed, is indeed equal to x minus a times the quotient, which is x squared plus ax plus a squared. Perfect. So that is how you have to do it. So I hope the steps are absolutely clear. Now we are going to use this formula, which is also called difference of cubes, right? In factoring. So that will be actually our next chapter. So I hope you find it easy and useful. So let's do question number 5 now. Question number 4. Derive the formula x cubed minus a cubed equals to x minus a times x squared plus ax plus a squared. What we see here is that remainder is 0, right? So the remainder basically is equal to 0. Do you see that? So that term is not there. It means x minus a is a factor of x cubed minus a cubed. Perfect. So what we are going to do in this exercise is basically divide x cubed minus a cubed by x minus a. Correct? That's what we are going to do. So let's do it. So let me do long division. Right? Now x cubed minus a cubed, two terms are missing here. Those two terms will be replaced by placeholders. So we got 0x squared plus 0x minus a cube. So remember, a is a constant. A is a real number. Let's say a constant is okay. So we are only working with one variable equations. And the divisor here is x minus a. So in the quotient, taking these two terms, we get x squared. So when you divide, we get x squared minus ax squared. And when you take away, we get ax squared plus 0x. So we have to multiply by ax. That gives you ax squared minus ax, a square x, right? And that gives you a square x. Bring down the next term, which is minus a cube. And that should go times a square, right? So when I write a square, we get a square x minus a cube, and the remainder is 0. Do you see that? Since the remainder is 0, we know x minus a is a factor, and we could now write that the function, which is x cubed minus a cube, is indeed equal to x minus a times the quotient, which is x squared plus ax plus a squared. Perfect. So that is how you have to do it. So I hope the steps are absolutely clear. Now we are going to use this formula, which is also called difference of cubes, right? In factoring. So that will be actually our next chapter. So I hope you find it easy and useful. So let's do question number 5 now. Question number 5. When certain polynomial is divided by x minus 2, its quotient is x squared minus 2x minus 3 and its remainder is 1. What is the polynomial, right? So we can always find the polynomial using product of divisor and quotient and adding remainder to it, right? That is the division statement, which we normally write in multiplication form. Now in this particular case, we are given that the divisor is x minus 2. The quotient is x squared minus 2x minus 3 and the remainder is 1. So just multiply these polynomials, x distributive property, we get x cubed minus 2x squared minus 3x. Now with 2 we get minus 2x squared plus 4x plus 6 and then we'll add 1, correct? So we just applied the distributive property. First we multiplied with x all the 3 terms and the rest 3 terms we got after multiplying with minus 2. So we have 6 terms. We'll combine 1, the constant, with them. Let's rearrange, combining like terms. X cubed, as far as x squared terms are concerned, minus 2 gives us minus 4x squared. The x terms, we have minus 3 and 4, which is plus x. Constants, 6 plus 1 as 7. So that becomes the function as such, right? So that is how you get your function. Now as an exercise, I like you to check solution. How could do it? You could divide this function by x minus 2 and see if you get the required quotient from where we started. Reverse calculation. Question number 6. F of x is divisor times quotient plus remainder, where remainder is not equal to 0. With the degree of quotient as 4 and degree of divisor as 2, find possible degree of remainder, right? So what we are doing here is basically dividing quadratic equation. So this is something like x to the power of 4 something, right? With degree 2. So we have x squared times something, right? So what do you get degree of remainder as? This is what the question is. So clearly it could be less than 2 only, right? So it could be linear or it could be a constant or it could be 0, right? If it is a factor. So in either case, linear means degree is 1, constant means degree is 0. So that is what the degree could be, right? So there are 2 options. 0 and 1, option D is the right option. Perfect. Now let us see how to solve question number 7. If f of x is divided by x minus a, as explained earlier, the quotient is lowercase q of x and the remainder is r1. If q of x, that quotient, is divided by x minus b, then the quotient is capital Q of x and the remainder is r2. Find the remainder capital R of x when f of x is divided by the quadratic function x minus a divided times x minus 2. Is that clear? How can we do this question? Now let's write division statement for each. So first one, we can say f of x is really equal to x minus a times q of x plus the remainder R1, right? Now what are you doing? You're trying to divide the quotient, so we can say Q of x is equal to this times that, which is x minus p times capital Q of x plus the remainder R2. Is it okay? Now we can substitute this Q of x value back into the very first equation and get the final remainder, right? So we can actually substitute this value of Q of x here. So we could rewrite our first equation as f of x equals to x minus a times, instead of Q of x, let me write within bracket x minus p times capital Q of x plus R2. Does it make sense to you? And plus R1. So what we did was that we substitute the value of Q of x in equation, the first equation. So let's call this as our equation 1, this as equation 2. Now we can expand, so we get x minus a times x minus p times capital Q of x. Now that gives you this part, right? So this is capital Q of x, this capital Q of x, right? Plus x minus a times R2 plus R1. Does make sense to you? So what do you notice here? You clearly notice that your final remainder is this. Correct? So that is the divisor, x minus a times x minus b. That's the function f of x. And if you compare the division statement, what we get here is the remainder, right? Which is x minus a times R2 plus R1, right? So option B is the right option. Now this is extremely important question and will help you to solve many critical multiple choice questions in IIT JEE or similar test papers. I hope you appreciate it. Now let's take up question number 8. If f of x is divided by 2x minus 1, the quotient is capital Qx and the remainder is capital Rx, as shown here. If f of x is divided by x minus half, the quotient is small qx and the remainder is R of x. Which of the following statement is true? Now, look at the divisor. In the first case, the divisor is 2x minus 1, right? This is case 1, right? Now, in the second case, what we have done is we took 2 common and then we could write this as x minus half. So this is case 2. But in case 2, we are only doing division by x minus half, not by this 2, right? So basically, what we have to do is, we have to do case 2 divided by this number 2. So we actually divide by x minus half and got this result, right? But we did not divide by 2. So that is how they're different. Do you understand? So this quotient is twice capital Qx, and so we will see that Q of x is actually 2 times capital Q of x. To get the net result, we should divide this by 2. Perfect? So if I have to do times 2 here, that means that should be divided by 2, is it? Because the divisor, do you understand? However, the remainder will be same, right? So the remainders remain same when you divide by this, but the quotient is double when you find. So Q of x is twice capital Q of x. So the correct answer is option D. Q of x is twice the quotient which you got earlier. So to get the final answer, you should divide this by 2. So I hope this is clear, right? Now let's take up the last example, which is question number 9. Apply division statement to find remainder when f of x equals to x cubed minus 3x squared plus x minus 2 is divided by x minus 1 times x plus 2. Now I'd like you to pause the video, answer this question, and then look into my suggestions. Now let us try to understand how we can solve this question. Now since the divisor is quadratic, we expect remainder to be linear, right? So remainder should be linear. That means, let us say ax plus b could be the form of remainder, right? Now let's write down the division statement, which is f of x is indeed equal to the function divided by, let's say the quotient is q of x. We are only interested in the remainder, right? So let's say q of x is the remainder. Then we could write this as x minus 1 times x plus 2 times some quotient q of x plus the remainder r. Now that remainder is ax plus b, right? So we are saying f of x is equals to x minus 1 times x plus 2 and some quotient q of x plus remainder is ax plus b. Does make sense to you, right? So what we are trying to say here is that when we divide this function f of x by the product x minus 1 times x plus 2, we get some quotient q of x and remainder r of x. This remainder should be linear since the function is cubic and divisor is order 2, right? So 1 less than divisor. Perfect. So that is what it is. Now see what happens if I write f of 1 here. If I replace x with 1, I get 1 minus 1, which is 0. 1 plus 2 times q of x plus a plus b, right? This is what I get. So 1 minus 1 is actually 0. So f of 1 is equals to a plus b. You get the idea, right? So f of 1 is a plus b. So let's find what f of 1 is. So what we get here is that f of 1 is equal to a plus b. Now similarly, if I substitute minus 2, in that case, x plus 2 becomes 0, right? So anything times 0 is 0. So we get here, substituting minus 2, we get minus 2a plus b equals to f of minus 2. Is that clear? So if I substitute minus 2, this term becomes 0, right? So we are left with minus 2 times a, right? So that really means that if I know what f of 1 is and f of 2 is, minus 2 is, I can find a and b. We have got 2 equations and 2 unknowns. Perfect. So let's find what f of 1 is and what is f of minus 2, and then it should be simpler for us to solve this equation. So let's write f of 1 first. So f of 1 really means substitute this x as 1. So we get 1 minus 3 plus 1 minus 2. And that is 2 minus 2 is 0. We get minus 3. And f of, let's write, f of minus 2 should be minus 2 cubed minus 3 times minus 2 square plus minus 2, right? That's what we get. And this could be written as minus 2 cubed is minus 8. That is 4 times 3 is 12 minus, this is minus 2, and we get minus 2. So what we get here is a negative number, minus 24, right? So this is minus, all are negative here, okay? So what we get here is minus 24. So we know what f of 1 and f of 2 are. Substituting these values, we could write minus 3 equals to a plus b, and minus 24 is equals to minus 2a plus b. So we have two equations to work with. Let's call them equation 1 and 2. So how can we find a and b from them? Well, let's do it here. If I take away one from the other, that is to do one equation minus equation 2. So if I do this minus this, I get what? I get 21 here, right? 21 equals to a. 3a rather. So if I do 1 minus 2, that becomes positive 3a, and this applies a equals to 21 over 3, which is 7. So we get value of a as 7. Substituting 7 here, minus 3 equals to 7 plus b. So we get minus 3 minus 7 equals to b, or minus 10 is equals to b, right? So we get a equals to 7 and b equals to minus 10. Perfect. If that is the case, then what is the remainder? In that case, the remainder is, which is ax plus b. A is 7, so it is 7x, and b is minus 10. Perfect. So that becomes the remainder for us. Is that clear? So what I'd like you to do here is to verify this answer. Just divide f of x by the product, right? You could expand and divide and check the result. I hope you find this exercise extremely important and useful. I've actually included some very good test questions which could also come as bonus questions in your exam. Feel free to write your comment, share your views, and if you really like and subscribe to my series, that would be great. All the best.